You don't always own the codebase that you want to build extended functionality for. In some cases, you're not even permitted to introduce a subclass, or simply, it's just not a desirable solution. Extension methods, as you will see, are not limited to classes. I'd like you to imagine adding a method to all types that implement a specific interface. This is a truly powerful way to create a reusable piece of code that can be shared across all your projects that use those types. Of course, there are multiple ways to build helper classes, but using something called an extension method allows you to create a method in a completely separate library that acts like an instance method on the given type. It can be useful to provide completely new functionality or act as a method overload by accepting different parameters than what the method on the existing type does. You should only resolve to this when you do not have the capability of extending the original class. If you are building a library of helpers that extend functionality on a given class, sharing this within the business or on NuGet can prove really helpful. Extending a type is fairly simple. You need to follow a basic pattern. First, you need a static class that holds all the extensions for a given type. It's a good idea to create one class per type that you want to extend with additional methods. Let's say that you want to extend the order. You'd create a class which you'd call order extensions. This class can now contain static methods that have the sole purpose of acting like an instance method on the order. The method signature for an extension method is slightly different from what you're used to. You define the return type and the name for the method just like you normally do. Where this will start to look a little bit different is when it comes to the parameters. The first parameter will be the type that you are extending with additional functionality. To define that this is an extension method for the order type, you use the keyword this, followed by order and the name for this parameter. What this now means is that this method could be used like an instance method on the order as long as you include this library and use the namespace. The compiler will take care of passing the actual instance as the first parameter to this method. Really, this is just like introducing a helper method, but it acts like it lives on the order itself. This is also why you'll only be able to access properties and methods on the type that you are extending, which are public. You could add additional parameters as well. This would mean that when you invoke this method on an order instance, you have to pass that parameter, just like a normal method call. Of course, we own the implementation of the order class, so creating an extension library for this wouldn't make much sense. It would be better if this functionality lived somewhere else. You may be wondering what happens if a method already exists on the type that matches the exact signature that you are creating using one of these extension methods. The compiler will make sure that the extension method would never be used if the type has a matching method signature. This means extension methods have the lowest possible priority. Since the extension method is a simple static method, you could of course call it directly, which also explains why you're not able to access private fields, properties, or methods on the type, because internally, this is exactly what's going to happen.